So once you have preprocessed your data and create the two files, the cellophane and the boundary condition files, you can upload them in the TwinLab environment in order to be read by the TELEMAC 2D model. And in addition of these two files, we also need a steering file that is the main simulation file where you define the boundary, how to read, for example, the other files, the boundary condition and the cellophane. And also you give the initial conditions of your simulation, the time steps, etc. And we also need the discharge stage information file, which can be also edited by a text editor. So in this case, for the discharge stage information, we have, for our test case in Grunoy, the tributary that is unregulated. The information is coming directly from the HYPE model, which is also implemented in the TwinLab environment. And we have the assumption made for the discharge in the upper part, since we are simulating this bypass section river. So we have simulated a regulated discharge in the upstream boundary, the unregulated from HYPE hydrological model in the tributary, regulated from the other tributary, and then define a stage curve for the downstream boundary condition. So yes, we have created a simulation for an steady case where we make the assumption that and simulate that the flow will decrease and then increase again. And for our model, we have divided in two runs for the TELEMAC, where we have first a steady simulation up to until the 7,000 second in order to provide the initial data for the next unsteady simulation, so having a hot start simulation. So I will now show you how we start running the TELEMAC model, but just before, so remember that we need to have the 4 files in the TwinLab environment, and we have the boundary conditions file, we have the cellophane mesh file, we have the boundary conditions. I can show you an example of how you can also modify it with the text editor, and we also have the cache file that is our main simulation file. So then we can run the TELEMAC. It will be compiled and it will take a bit. This is the first, the steady simulation. So I can also say that a very good point of having TELEMAC inside the TwinLab environment is that I can run it from everywhere I want. I don't need to go through the process of installing the software. And I can have also my data in this environment, so it's easier to be run anytime you want. And also just to mention that for the preprocessing part, in theory, unless you change your bathymetry, this will just need to be done once. And then within the TELEMAC, you can modify the, for example, boundary conditions, you can modify the certain nodes, so it can all be directly done inside the TELEMAC within the TwinLab environment. So now it is running. It will take more or less time depending on the time step, how long your simulation is, and also the graphical and the printout interactions that you have defined or set up. And then when it is done, we will see, yeah, here you have also printing, is getting print out some of the information. So the data, the number of elements from your cellophane and the mesh file, which type of element it is and how the mesh was defined. Then the boundary conditions, and also we can see them at different time steps that we have defined to be print out the information. We can follow up how the model is going through the simulations, and then when it is finished, we will get a message that says that, yeah. So the work was done and was finished, and then we have the first simulation done, and then we say, I will not run this now on the video, but then we can define in the next CAS file or the main steering file that it will start reading the previous simulation results file. So then we see that it's actually reading these previous files in here. So yeah, and starting at 7,000. So then we have our model also done.